I'm Frederick. So before we kick off, quick question. Who's ever worked with legacy code? Nice. A lot of people. Okay, who enjoyed working with that legacy code? Okay. It's about 5% of those people. Okay, so this talk today is obviously about legacy code. You might have noticed my accent is a bit off. No problem. I themed this entire talk in an English way to relate to you people. I've put in a bunch of references which I don't understand myself. Hope you'll enjoy them. Don't worry, for the political stuff, we're not going to discuss the situation. I think we all know what I'm talking about. I have no idea who that person is. Okay, so this is me, the beautiful stallion. That's me. Frederick Vanbrabant. Yeah, that's how you pronounce it, Vanbrabant. My Twitter handler is maybe Frederick. I have a blog, frederickvanbrabant.com, where I rant about delirious things. I'm a keyboard for hire. I have my own company called BRODY and Hooper. Sounds pretty professional, right? Cool. So, about the accent. I'm Belgian. Normally people rise for the flag, but okay. Remain seated, it's okay, it's okay. I feel that Belgium and Britain always has this great connection with each other. For example, one of your famous PR people once called us a bunch of fat, lazy, BEER-SODDEN pseudo-French bastards. Yeah, thanks about that. Yeah, we like you people as well. So, okay, about the talk. Let's first start off with an analogy, which I kind of shoehorned in. British people are known for their bespoken ways and their fashion sense, so I'm sure a lot of people know what watches we're looking at here. That's quiet. Anyone? Anyone? I assume you at least know one of them. Right? So yeah, this is an Apple Watch. The other one? There you go. We got a winner. That's the Omega Speedmaster Professional. Bit kind of difference between these. This watch goes for around 300 euros. I don't know what that is in pounds. Probably 5,000 pounds by this time. This one actually goes for 5,000 euros. This watch does a lot of things. It measures your heart rate. It can detect heart anomaly stuff, like diseases and stuff. Pretty cool. Manages your agenda. Can do your tax returns. Super excited stuff. This one keeps time. The kicker here is it keeps time badly. It loses about 5 seconds a day. It's inaccurate. 5,000 euros, 300 euros. Bit strange, right? This watch was first released a few years ago. Well, they made quite a deal about that. This one was around the 60s. It had its biggest PR campaign in 69 when some guy wore it while he was stepping on a big rock in space, the moon or something. Yeah, Neil Armstrong wore this. Not this one, but the Omega Speedmaster on the moon, which was pretty cool. I think that's pretty cool. So you might ask yourself at this point, okay, we have a super expensive watch that loses time. Its only function is to keep time, and it doesn't do that all that great. Why would you send it to the moon exactly when quartz watches, which are very accurate, were a thing at the time? Well, the main thing here is that this watch is repairable. A quartz watch is repairable, but not as repairable. You need a lot of knowledge to repair a watch like this, but it can be done. The thing is, this watch, in about a year, will be a bit outdated. It's not useless, but it will be a bit outdated. In 10 years' time, it's obsolete. Let's be honest, it's going to be obsolete. In 40-year time, well, you'll be kind of a hipster wearing an Apple Watch, let's be honest. This watch, if you wear it today, No problem, it's cool, still looks cool. If you walk into a watch repair shop with this watch, they just accept it, they congratulate you by wearing a cool watch, they fix it, charge you a lot of money for it, but okay, if you walk into an Apple store in 40 years with an Apple Watch, they're just going to laugh at you. So I'm not saying that one watch is better than the other, it's just they have different functions. This one is built to function, they have a lot of features. This one is more built to last and has more repairability towards it. That was an analogy. Okay, next up, another pop quiz. Anyone know what this company is? Yeah, we're lowering the scales now. So this is Facebook, obviously. The thing in Facebook is, some of you might remember this, I certainly didn't, but in 2007, there was this famous day where you logged into Facebook and instead of your beautiful farm, you saw the source code of the index.php from Facebook. Awkward. To be fair, that wasn't very pretty code. It was 2005, so cut them some slack, but well, the first 7 lines were require once, and like it was a huge file with comments and like it was really impressive. You can find it on GitHub if you do a quick search. I wasn't brave enough to put it on my slides because apparently they're a bit lawyery on that part. But the thing I'm getting at is Facebook still runs something like PHP today. The code you've seen at 2005 probably won't still be run at Facebook. No, it would be refactored. But the big idea is that they gradually refactored it. They didn't do the thing Twitter did, for example, by rewriting it in a new programming language and then rewriting it again and stuff. No, they kept the basic idea of the code and iterated upon it. They didn't throw it away. They even went so far as to build, they forked PHP to make it more, to adapt the programming language towards the code they had. So they actually went a very big way into refactoring the code they had. That was another analogy. So what am I getting at? The thing is, the value of the code itself is more important than the code itself. Okay, I have a cool quote about this by this guy called Ed Sheeran. Ed Sheeran once said, "I'm in love with the inheritance value of a code base." What did he mean by that? So the thing is, if you have a legacy project, it's very important to realize that there's a lot of value in that code. The code itself might look not ideal, it might look all over the place, but do remember that a lot of value is already put in there. For example, you have your user stories. Why do you have your user stories? Because you already have a bunch of clients. And there are so many clients that, well, the application itself probably has a lot of value because otherwise it wouldn't have any clients. If it didn't have any clients, it would be thrown away ages ago. Also, all the requirements, all the scaling, all the research has already been done. The only thing lacking from a legacy application is, well, the code quality. So actually you have this rough diamond that you just need to polish and, well, you have a real diamond. So that's cool, right? So, okay, the big idea of this talk is you've been thrown in a legacy application and you kind of are not looking forward to it, but we've established that there's a lot of value there, so you're kind of eager to jump in. But how do we actually start with refactoring code and stuff? So I split this talk in 3 big pieces. First of all is the mentality of how we should build and maintain legacy code. Second off is the code mentality. This is basically around surrounded by good principles and how we should go about it. And the last part, that's just the most important part, I guess, is how we can actually, one way to refactor code and dive a little bit deeper. So that's more an action plan. So as I said, first things first, mentality. First thing about the mentality is obviously knowing that you have legacy code, but we covered that, right? We're all there. Rewriting. a lot of people might think this is the first step to seeing the code. You see the code, it has a billion switch statements, it's if statements all over the place. Okay, throw it away, let's rewrite it. Okay, that's cool. Normal reflex, everybody's been there. Nothing to be ashamed of. The thing is, how are you actually going to do that? If you think about it practically, it's really hard. So are you going to split your team in half? Have a team A and a team B? Team A will do like the new cool application, and team B will do like maintaining the old code. Yeah, I think you might not have a team B in a few weeks anymore. So that's not actually a thing. Also, what are you going to do with features? Are you going to do a feature freeze for like 5 years? That's not how you run a business, right? So thinking about rewriting the code makes sense at first idea, but like if you think a little bit deeper, it's actually very bad value for your business. So my first advice would be to not rewrite. I must note that everything I say in this talk is obviously dependent, is more a general idea. There are obviously edge cases where you should rewrite, but it's all, this is more like the grand idea of legacy code. So I got another pop quiz. Does anyone know who said this? That's a Zuckerberg quote. Or as I like to call it, a person that never worked with legacy code. So moving fast and breaking things, it's all great once you're a startup and heading towards like time to market and trying to get your customer base there and trying to establish yourself in the market. But you have legacy codes. You're already in the market. You already have your customers. And well, the biggest problem here is that your code is great. And when your code isn't great, it's sometimes directly related to moving fast and breaking things. So my great advice in legacy code would be don't move fast, move slow. Why? Why not? Just like think it out. Have some meetings, like get some people together in a meeting room that's free, like hours doesn't cost a thing. Get them all together and think it out. See where you want to go, where you are, where you want to go. Have a battle plan. Like think it out. And you have the time, you have the resources, obviously, because you're a big company at this point. So move slower, think it out, write tests, like have an actual idea where you're going. Don't just blindly jump in. Something a lot of people always kind of forget about these kind of projects is documentation, setup, all those things. Ideally, you would like to have one repository where you can take a new developer, drop him or her in, and say, okay, I'm going to check back on you in like half an hour, everything should be running. Who has that? Cool, he has it. So yeah, it's a rare thing, but it's something you should want to achieve because it's really important to just have that out of the way. Legacy code in general is hard code. And if you have just a repository where you can just go and do Docker Compose up or Vagrant up or whatever up, that's half of the battle won already. And as G.I. Joe said, that's the most important part. Also, documentation, very important. This might be very obvious to you people, but write it in English. Great tip there. The rest of the world, write it in English. So people from England can join us. Yeah. Okay, cool. Automate and analyze everything. This is like the build ID. This is very obvious for greenfield projects, for older like brownfields projects. It's less obvious. What's so cool about automating and analyzing these things? Well, automating, for example, you can do a code quality automatically cleanup. There's this thing called the broken window principle. I'm not going to dive too deep about it, but the idea here is that if you look at code and it has like indentations all over the place and it doesn't really look good, it can function perfectly, but it doesn't really look all that well, then the code is perceived as less valuable. Let's get that out of the way as quick as possible. Try and run some code cleanup tools over it, where the indentation is fixed, where some white spaces is added, all those small, tiny, insignificant things, but it really adds up. The downside here is you're going to lose some Git annotation stuff, who did what, but you're working in legacy code, so probably you don't have Git at this point. So, okay, there's also these things called tools like Code Climate and Scrutinizer. For the people who are not very familiar with it, what they tend to do is they analyze your entire project and they give it a score from A to, I think, E for code quality. And they also do it per file. Now, the first time you're going to run it, it's going to be extremely depressing because you're going to hit an E. Yeah, that doesn't sound all that well, but it gives you a goal to work against. It's a great feeling to refactor some code and see your code go from E to maybe a C. That's cool. That's a reason to celebrate. Celebrate often, so celebrate. And if you can keep doing that and your entire project goes from a C to maybe a B, that's another milestone. And it gives your team something to work against and something to motivate them. So that's really cool. That's fun. Controversial one. Stop thinking about your favorite framework. Okay, I'm going to dive a bit deeper in here because there's some layers here. If you're working, which is almost always the case, in some application that some old CTO invented and built their own framework, that should sound a bit familiar, probably. Don't try and shoehorn something like a Symfony or a Zend or a Laravel into there. That's not going to work. You're going to lose a lot of time there. Stop thinking about the framework at all. Just try and move more towards loose packages. Try to replace the crappy built router, for example, and input the Symfony router or like some other big package router in there, and like try and replace files like that. Now, if you're running stuff like a Zend 1, a Symfony 2, or I know a Laravel, I don't know, then that's another case. If there's a clean upgrade path, take it, by all means. Take it, try and work towards a cleaner version of whatever you have. If there isn't a clean upgrade path because everything is hacked together and the stuff in the kernel has been changed and stuff, then I would advise, and this is extremely controversial, hopefully it's not recorded, I would suggest not upgrading. There. I would say cut your losses. Look at your application you have. If it's hacked together, if the kernel has been changed, if a lot of files have been changed, realize you're not running a Symfony 1 anymore. You're running some kind of Frankenstein monster version of that framework and treat it as such. Try and think more in the sense of this is like a framework hackled together by some old CTO. Well, it's probably better, but it's still not great anymore. So try and like replace bundles from that application and try to like fit it together and more. Also, for the case you're like running an old WordPress stuff or Drupal stuff or other CMS kind of things, I have no idea. So sorry. Okay, so I have another great quote, and this really hits home. So Jamie Oliver famously said, working with legacy code is about stepping out of your comfort zone. And that's really the case. Legacy code forces you to rethink the way you handle code. If you're always working in greenfield projects, well, this is maybe the moment to like step outside of that comfort zone and try and like reanalyze everything, try and re-challenge your ideas you had before about that code. So, next chapter. Cool. Everybody still excited? Yeah. Yeah. Woo. Yeah. Okay. I might be a bit too excited. Okay. Code mindset. Code mindset is actually more related to good practices. The thing about good practices is they're super practical in legacy code because they're there for a reason and they haven't been there before. So most of these should ring home and should be applicable to all applications, and we'll dive back deeper into that later. So first of all, keep method and classes small. Who's familiar with Uncle Bob? Everybody's familiar with Uncle Bob once said something about classes lengths and method lengths and indentation lengths, which is, I should have wrote that down, but it was something along the lines about, I think a class can maximum be like 40 lines, 2 methods and 1 indentation deep. Yeah, I might totally be misquoting that, but it was something like that. Don't take the numbers, but take the idea there. The idea here is that it forces you to think in single responsibility patterns. Like if you have classes that are like 1,000 lines long, that class is doing way too much. That's reality. So try and refactor code like that in towards smaller classes. Smaller classes, if you have a lot of classes where your code runs through, there is this small performance loss. People say that it's performance loss, but if you're running legacy code, that won't be your performance loss. Your performance loss will be all over the place. So I would advise to working towards smaller classes, small methods, and like the 1 indentation rule, well, do it maybe 3 indentations, 2 indentations, but don't like have those pyramids of if stuff. You know what I'm talking about. Related to that, keep PRs and commits small. Who's familiar with atomic commits? Yeah, cool, 2 people. So yeah, the thing here is that your commits are very small, atomically small. Yeah, that's the name. So how does that work? For example, you have this big controller, like huge controller, which is, yeah, you've seen it before, and you want to like extract a part of that controller towards a helper class or a command bus or whatever. So how would you go about that? First step is, okay, we're going to create a new class. Okay, we create a new class, that's a commit. Just the new class, create empty class, that's a commit. Okay, and now we're going to copy the code over, which we want to refactor to that new class, bam, that's another commit. Okay, now we're going to remove the old code we had in the controller, delete it, that's another commit. At this point, very important to note, the commits are broken. And that's okay. You can just put that in your command, in your commits message. At this point, the application is broken. Then, next commit would be linking those classes together. And then you can go into refactoring in small spaces every time a single small commit. This sounds like a lot of work, and it is. But the cool thing is, you're thinking about what you're doing, and you're telling a story towards your commits. So every commit is a small story, and once the code reviewer comes along, or reviewer, yeah, English, they can follow along. They can just see the messages, okay, this is happening, okay, I can follow, okay, this is happening. And the thing is, with legacy code, there's so much code, and it's all over the place. It's hard to follow. So tell a story with your commits. Also your PRs or MRs or whatever you want to call it. Okay, you can have like multiple MRs per feature. That's okay, it's totally okay. If they break the application while you're working with them, well, link them together, tell it, document it, like communicate with people, and everything should be okay, I promise. Next up, related to that one. Code reviews. Everybody does code reviews, right? Yeah. No. So the thing about code reviews, for the people not initiated into code reviews, it's reviewing each other's pull requests and merge requests and whatever the cool kids call it is these days. So you review each other's code. I've worked in a few companies before where there was this 3-thumb rule. The 3-thumb rule is everybody who reviews the code has to, instead of accepting it, put up the thumb emoji for a thumb. And if you have 3, you can merge it. That sounds sensible. It also sounds slow, and it is slow, but we're not moving fast. We're moving slow. Okay. Also, another thing to notice is there shouldn't be one person in your company reviewing your code. That shouldn't be I've worked in companies where there's one person who reviews all the code, and it's kind of like a gatekeeper kind of thing. And he or she, well, doesn't do anything besides reviewing code. First of all, for that person, it's extremely boring. And the second is, that's just like one pair of eyes, and you're kind of losing out on the biggest advantages of code reviews. And that's sharing knowledge. Code reviews gives you the great idea of like reviewing what someone else is working on, not only about the code quality and the code structure and architecture, but also like what's happening in that domain. And we'll move further in that later. But like it shares what everybody's working with, and you can touch pieces of code without ever having like to program in those pieces of code themselves. That's great. Another thing to notice is I've worked in companies where the idea was that only senior developers could review code from junior developers or media developers. I'm not a fan of that. I think everybody should be able to review each other's code. Meteor can review senior's code, senior, meteor, even junior, that's okay. But like if you have like the three-thumb system and it's only juniors all around, maybe have someone meteor or senior take an extra look at it, not to like enforce anything, but more just like extra security and maybe help around a bit. So I think that's really cool. Who's a fan of pair programming? Mob programming? Who knows what mob programming is? Yeah, well, mob programming is a thing like pair programming with a lot of people. It's horrible. If you have interns, perfect thing to do. Don't do that. So, pair programming. I've worked in a company where everyone was required to pair program all the time. Horrible idea. It's really not fun. The thing is, you have obviously introverted people, you have extroverted people, but that all goes out the window when you can't like have a few minutes for yourself. You can be the most extroverted person in the world. If you're pair programming all the time, you will have a bad time. But that doesn't say that you shouldn't be pair programming. Pair programming can be super efficient. Like take breaks every often, like every hour or something, have a break. Switch up the driver and the navigator. The driver is the one on the keyboard. The navigator is the person who just sits back and just sets some IDs and takes all the credits. So switch those things up every half hour or something. To keep it interesting, you can do the ping pong thing where you just do every 5 minutes. Also, another great idea is to like do this thing called mini meetings. I just made that up. The thing is, first you sit together and see what you're going to do. Like sketch it out, kind of. And then you start together and lay a foundation of, okay, we're going to work towards this goal and then go this route, and then split out and work each other, like separate from each other, and like each work on a part of that plan. And every half hour or maybe every hour, come together and see where you want to go, and then just have a quick conversation about it. Again, this costs a lot of time, but we're moving slow, and that's great. And we're thinking things through. That's the most important thing. We're thinking things through. So I have another great quote. This is a pop star. So, as I said before, legacy code gives you a great insight into why some good practices exist. This is, I think, very, very valuable. Good coding practices really shine in legacy applications. And the big advantage of applying them in legacy applications is you can perfectly adapt those good practices to greenfield applications. Keeping classes small, keeping atomic commits and stuff, that perfectly works in greenfield applications. So you're not losing time anywhere, you're just like kind of reinventing yourself as a better developer, I think. That's cool. Okay, the big meat of the application, the talk, getting started with legacy code, like actually diving in and working with the code. A quick announcement before we dive in. This is a solution. There are a million of them. Legacy code is very unique. There are a billion problems there, but this is a way to go about it. Always take this with a bit of grain of salt, and this might not fit your current problem. So first thing you really need to get under control is your builds, git, and deploy. A lot of legacy application doesn't have git or version control, which is like git and SVN and that other thing. there's another one, right? What? Yeah, that one that nobody ever uses. And the deploys, also get them as quick as possible under control. Why do you want these things under control? You want to be able to deploy with a one button click. Why? Because you want to revert with a one button click. If an error comes to your production and it breaks everything down, you want to be as fast as possible to move back. This gives you the great benefit of having a safety net. Like if you mess up, okay, we can roll back. Nobody to blame, we're just like we made an error. Things happen, that's okay. So try and get it under control first. This will cost a bit of time, but it's definitely worth it. Second of all, use a debug tool. I myself, and I know a lot of people, are sometimes a victim of using the dump and die methods of development. I think you know what I'm talking about. Like var dumping a variable and then dying and then refreshing the page. And yeah, that isn't the most professional way to go about it now, is it? And okay, that's okay, but if you're working in legacy code, there's so much going on. I would definitely advise tools like Xdebug, where you can just add breakpoints, step through your application, step through your methods, see where you're heading, see what everything is happening. It's, I'm going to be honest, it can be really a pain to set up with Docker. That's the thing. Everybody knows that. But I would still advise you to take the time, set it up in Docker. You're going to win a lot of time afterwards, and you're going to stumble upon bugs you might not have noticed before. I got another controversial one. Use a full-on EDA. So I know a lot of people are very fond of stuff like Sublime and Code and Atom and other things. VS Code? Yeah, VS Code. VS Code is really cool. The thing here is that's totally okay on Greenfield. But if you're in like the catacombs of legacy code, I personally would advise against that. I would advise you to use stuff like PHPStorm or Eclipse or NetBeans or, yeah, name three. Three is enough. I think then you have more capabilities to discover the code, you have more tools. It's slower, I admit that, it's slower to work with, but the advantages are real. They give you a broader sense of the code you're dealing with. There's only one exception. And that is if you use Vim. Yeah, you're already way beyond this point, so there's nothing I can tell you to switch away from Vim, so you keep on doing you. You beautiful bastard. So, okay, next up. This is actually diving into like the meat of more like actual the code. I recently saw a great talk about it. It's about adding tests to applications. I really like stuff like that. So yeah, first things first. When you dive into legacy code, I would advise after you set up like the deployment stuff and then use an EDA and set up the EDA with Docker and stuff, this is the point where you're actually going to write some code. And I would advise to now, this is the perfect time to write a lot of end-to-end tests. You might be calling me out at this point if you've been paying attention, because at this point, you might think we're putting a stop on new features, because you can be writing end-to-end tests and develop new features. Well, how would I go about it? You create a feature stop and write end-to-end tests, but business won't like that at all. Or you can now, every new feature you implement, every bug you fix, every change request, write some end-to-end tests first, and then do the change as you would before. This will take some time, but eventually your test suite will grow bigger and bigger, and you now are creating an extra safety net, which is very, very important to have these things. So first of all, a lot of end-to-end tests, great time to sit together with a domain expert, something like a manager, a client, or whatever, and see what your application actually does. Because a lot of legacy code has a lot of features that nobody knows about. Also, some features nobody uses. If nobody knows them, nobody uses them, well, you can drop them. Everything you drop, you don't have to maintain. That's cool. You're winning time here. Okay, next up, you've written a lot of end-to-end tests. You feel a bit secure about yourself. Okay, let's write some new code. How would I go about it? Write outside in. Okay, great tip there. Nice. Okay, let's illustrate. This is your legacy code base. It's not a sad emoji. It's not really happy or sad because it has a lot of value, but it doesn't have great code. We're going to fix that by, first of all, adding all our end-to-end tests. Still not happy. And now writing all our new shiny code around that. This is what we want, right? We want the shiny code and like the business value of the old legacy applications. Now, that's cool, but well, we have this kind of mismatch here. We have the code we want to have, and we have the business rules, but we don't have the connection. So let's illustrate it with some code examples. Can everybody read this? Is that readable? Interaction? Yeah, it's readable. Okay, so I'll spell it out a bit. So we have a typical legacy PHP file. It's not a class, it's a file. First of all, we have a million things happening on top. That's imagination land here. Then we create a new MySQL E connection. We're going to Food Inc. We put our credentials there, and we create a new connection. If that connection isn't established, we die, because that's what legacy code does. It just dies. Then we create some raw SQL, because everybody loves raw SQL. We insert some food. In this case, crumpets. I learned last week what a crumpet is. Still haven't had one, but I know what it is now. And then we create the connection in the query, and we close, and the rest of the business logic happens below. Let's say we want to refactor this. How could we go about this? Again, this is a way to go about this. This isn't the way to go about this. We could create something called a translation layer. A translation layer might look very strange when you look at it. First of all, it got some really strange things. We start off with a static function. I'm not a fan, personally, of static functions. No interaction? Okay, great. Everybody's a fan of static functions. And then we get the container. No? Okay, sure. And from that container, we get the repository, and on that repository, we do the add food, and we do the repository stuff. Now, I personally don't think that's very nice code. I might be alone there. First of all, static functions are hard to test. There are some people with other opinions about that, but we're not going to dive too deep in that. We get the container. We get stuff straight from the container, which is, I think, not a great thing because dependency injection and all those things. So that's a bit strange, right? But okay, let's carry on for now. We have this translation layer, and that add food repository looks like this. And this is just a repository. This is example code. I only have so many lines, so I kind of squashed it a bit. And this has dependency injection, which is nice. I think we have some doctrine query builder stuff here. We create a connection. We no longer have the password stuff in here, which is now environment files or whatever. And we have some query stuff happening, which is more testable. Actually, this is pretty testable. This is actually code I wouldn't be opposed to having in my application. Compared to like the older code, this is pretty nice, right? Especially if it fits on like one slide. So this is cool. Let's see what happens. Like, this was the file we had before, and now we have something like this. This is nice. So what about that translation layer? How did we connect these two things together? Well, we moved from this to this. We now just have a single line, the fruit translation layer, add fruit in that big, huge, ugly file thing. Yeah, translation layers are a bit, they're a bit strange. But once we refactored this million lines of code to like 1,000 lines of code, to maybe 100 lines of code, to maybe 10 lines of code, your entire application of that file might look like things like this. Just translation layer files. And the cool thing about it, you can reuse this line everywhere. It's just one line. Everywhere where you're going to add food, you're just going to add this one line that refers to testable code, okay, nice code, which is really nice. And once everything are these lines, you can just drop this file, create a controller or whatever helper class, and just like no longer need this translation layer. You can drop the translation layer, and you have nice code. Easy as that. Great. So at this point, you created your first refactoring. Now let's add all the other tests. I'm talking about end-to-end tests, unit tests, smoke tests, mutation tests, and all the tests he talked about. So yeah, now is the perfect time to add a lot of tests. And yeah, be merry about it, I think. Now, this is the part of the talk a lot of people might refer to, like, hey, I heard some cool things about this thing called a microservice. That's perfect for legacy code, right? The thing is, at this point, I wouldn't advise going towards microservices. Again, this is just generally, I'm not talking about every application, I'm not talking about what you should and shouldn't do, but at this point, personally, I would advise towards going to microservices, because you have a lot on your plate at this point. You're refactoring code, you're diving into uncharted territories. Legacy code application companies aren't known to have huge DevOps teams. You might be biting a bit too much before you can chew, which is probably not an expression in English. So I wouldn't go for microservices at this point. You could, but I wouldn't go towards that. But if you were to ignore everything I said, you could actually kind of easily do it at this point, because here we have the translation layer. Now, if we drop these lines and create a connection to a microservice, we're already there. Yeah. So that's great, right? Okay, that's one example of translation layers and how you can use them. They're very flexible. You could use stuff like command buses, you could do query buses, you can have like huge architectural stuff here. Then you might lose a bit of flexibility of what the translation layer can do. Command buses also have the somewhat, I wouldn't say disadvantage, but if you want to drop them in, sorry, I'm going to slide a bit back. In stuff like this, you need to inject them, and there's more setup to do instead of just like one line. But again, this is just one example. Okay, the word microservices has been dropped. Let's drop DDD as well, right? We're cool like that. We're not going to dive into DDD. That's a huge topic. I'm just going to do some IDs from DDD and see if we can attach them to what we're doing at the moment, right? So first of all, order per domain, not per action, is something kind of at the core of DDD. How can we, like, maybe in a light version, attach that to some legacy code? So a lot of legacy code tends to look like this. We have our namespace, our general namespace, we have our controllers, we have our models, we have our validators, transformers, whatever you can think of. They're all meshed together. The revised ID here could be something like this, where we have like still our top namespace, we have our HTTP layer where everything is like still mangled together a bit, but then we have our users and our post namespaces, and there they have their own separations. What are the big advantages here? Some of these advantages are pretty cool, where you can now easily put, if you have a huge application, put a team on the user domain and a team on the post domain. If you have like a team of 100 developers, you can split it up in 50-50. which is probably not a good idea, but you could. Then you kind of have the advantages of working with microservices, but you're still in the same repository, in the same application, but you now have your teams working towards a domain. Another cool thing is, if you have a user post class, you now have the dilemma where I'm going to put it. Am I going to put it in the user namespace or in the post namespace? And the right answer is neither, because your class is doing way too much. At that point, you should split it up. If you have a class that does user post validation stuff, then well, it's doing too much. It's either doing some user stuff or you're doing post stuff. They should split it up and connect those classes with each other, with other layer stuff. It forces you to think more in the more solid principles, where you split your teams up. Yeah, and also you don't have giant folders of controllers and models, which are way too big. Cool. Can't say DDD without value objects. I here have a user repository, and we're going to set some T. T references? But I do know what T is. So in this user repository, we're going to set some T. Here we have the amount of T, and the user we're going to set the T for, which is an integer. All right. Here we have the user controller. We import that repository. Don't make small variables like that. That's a bad idea. I should fix my slides. Here we have an update. We're going to go to the repository. We set the teacups. Pop quiz. What was first, the amount of T or the user ID? Everyone gets it always right. When I was creating those slides, I thought maybe. Yeah, it's true. Yeah, but still. Do you want to make that gamble? How many times a day do you want to make a gamble like that? If you mess it up, you won't get an error. If you have user 1 and 1 teacup, or you have user 5 and 3 teacups, you might be corrupting your data at this point. You don't want to mess it up. What's the obvious solution? Yeah, obviously, value objects, because I spoiled it 3 slides ago. So we're now going to create a user ID value object, which is just a small class. That doesn't sound very revolutionizing, but it kind of is, I think. I think it's pretty cool. So first of all, if you're now going to, you can't mess them up anymore. That's the first advantage. That's cool. And a value object like that might look something like this. Here we have the user ID, and we have our constructor, which still takes an integer and doesn't return void, because I forgot that. It does have validation built in there. You can't create now a user with ID 0. No, it's going to throw an invalid exception. So your values of your value object are always should be always valid. Right. We're going to reference it to the ID, which I forgot to set. And then we have a public function, for example, getValue, where you can just ask your user ID to get its value back, which still returns that beautiful integer. But now, if we want to work towards UUIDs, for example, we can now still do that. We can get a getAsUUID function, which does some magic, which I didn't write down. But you can handle now your user IDs inside of your application as UUIDs. You can still store them in the database as integers, but you can handle them inside of your application as UUIDs, which is cool. And then later on you can refactor your database, but you can still start working with them as at this point. That's the basic idea of why value objects are very cool. Another cool thing here is that if you make it immutable, which means you can't change them anymore, you no longer have to always reference your data towards your application. You can just pass along the user ID towards everything you do, and you can be kind of sure that your data is still, first of all, valid, intact, and unchanged, which is a huge benefit and really secures your code a small, tiny bit. So, okay, running on empty now, which is also an expression. So, I told you everything there is to know about being a legacy developer. You're all fully qualified now. Yeah, obviously I kind of skipped a few things because, well, it's a huge topic and every legacy application is totally different. So these are just general guidelines. There's a lot to talk about. There's a lot to learn about legacy code. This is a very rough framework to work towards. There isn't a one fit solution for everything. My biggest giveaways would be to like have great communication with the rest of your team, think everything out with as much people as you can, and dive in and see how you can experiment and where you can like fall and where you can't fall. This is something I think is really an important part. You're going to see a lot of funky things. What do I mean by that? You might see some things you have no idea how they work. Like, what the hell? Try and find out how they are built, which goes together with something. If you see some blocks of code and you think to yourself, oh my god, who wrote this? Like, what kind of hacky solution is built here? Whoever thought about something like that? It's very tempting to just throw it away, rewrite good code, and then call it a day. I would advise strongly against that. Try and understand why that hacky solution was there. It might be a performance thing. It might be some edge case you haven't thought about. It's probably there for a reason. Not everyone is as stupid as you think they are. So I would advise you to like dig a little bit deeper, and often you will see some extra value you haven't thought about, maybe isn't documented. And this is also a great time to like check out why it's there, and often these things can result in like a blog post which you can share with your team or just generally the internet or whatever. There's a lot of value here. Check that out. So this is kind of everything I wanted to tell about my experiences with legacy code and how I think you should treat it. If you want to learn more, there's this great book, Modernizing Legacy Applications in PHP. It's written by PM Jones. PM Jones is kind of a controversial figure. I would advise you to separate the art from the artist. The book itself doesn't have any politics in there. It's actually a very great book. Working Effectively with Legacy Code by Michael Feathers. It's a great book. It's a big book. You can learn a lot about that. I also said about trying to search for more like packages instead of like main frameworks, which is an option you could do. The League of Extraordinary Packages is a great place to start. Also, like the Symfony bundles are a great place to start, and like packages in general is obviously where you should head towards. Also, recently someone linked me a great talk about working with legacy code. It was by a developer who worked at Slack. I forgot to put it on the slides because I'm a professional. I'll link about it on Twitter or something. And it's a great talk. It's really a great talk. So I should definitely advise you to check that out. So everything that's left for me to say now is thank you. And now the best part, questions. Does anybody have a question? Yeah, sure, shoot.
You mentioned scrutinizer.
Excuse me?
You mentioned scrutinizer.
I did.
What advice can you give people to have a useful set of results from it, but not get too attached and always improve on score?
Don't get too attached to the score. Yeah, treat it with a grain of salt, obviously. You have a lot of setup you can do in tools like that. Set it up as you like it, but use that as a tool and not as like a guideline. Generally speaking, I personally really like the results they give back, and I think it's a great way to motivate people. But obviously, teams can differ in that regard. Evaluate what the tool does for you. Don't follow the tool blindly. If the tool doesn't fit what you're doing, drop the tool. There are a million other tools there. So I hope that gives a bit of a response. Thanks. Yeah, sure.
It's a very good talk, very funny. The understanding of British culture is brilliant. So I have 1 point to make and a question. I have a very exact opposite view of you on IDEs. I learned to code in Notepad.
Yeah.
I think junior developers should be like learning to code in bare bones systems like Atom, because then they learn about errors. I'd like your thoughts on that. But my main question is sort of similar to the scrutinized question: is do you think things like M-part complexity tests and psychomatic complexity tests can help guide developers working on legacy code to where to start? So like M-part will give you a complexity score for certain, and you might make a decision to either leave that code because it's too complicated or work on it. What's your thoughts on that?
The thing is, if you have this, you know the feeling where you have this like huge class, and everybody says like, that's the class, like try and work around it a bit. Well, you should avoid stuff like that. I think like the sooner you fix a class like that and tools like that to analyze your code and see where the pain points are, obviously, I think a good idea. But well, a tool can only say so much. And I think it's more like determining where the business value is and seeing where the money is made in your application. Try and pinpoint that first and try and make that as robust as possible, because otherwise nobody gets paid. That's just how the world works. And if you have like a huge class that has a lot of complexity and should be fixed and it's horrible code that's actually never really run, like it's a cron job that runs once a month and does something kind of insignificant, don't spend all your ammunition fixing that part, but try and determine where the business value lies. And if it's like a class that's kind of okay, but can be fixed, I would advise to first dive into that one. It's like, there's also this thing called like the 80-20 rule, where you have like, the 20-80 rule? A rule with 20s and 80s in there. So the idea there is where you spend 20% of the time to fix 80% of the issues, which would make it a 20-80 rule. So those are, I think, better ideas to like spend your time as efficiently as possible to dive into like the biggest pain points and the biggest points where your value can be increased for your business. I hope that's great. Cool. Anyone else? Yeah?
Yeah, so I really like that you said that testing is quite a good thing to do early on. What would you say in the cases where, especially with management that isn't technical, managers say tests are a waste of time? How do you deal with that? Shoot them.
So I would argue that if you're a business that relies on a website, you can be a banking company, you can be a tire manufacturing company, but if your business hinges on applications, then you're a tech company, because that's where you make money. If you're a tech company and you don't want to secure your biggest asset, then you're a bad manager. Also, the idea of an IT team inside of a bigger company is, I think, a very wrong idea, because well, as I said, if you're a tech company, your core business is that tech, so you need to secure it more. What I really think is that if a manager doesn't understand the principles behind where the money comes from, then they might be thinking in wrong ideas there. Obviously, that's pretty easy to say if you're a developer and they're like the business people and they can say, yeah, that's not true. I also think that it's better to ask for forgiveness than for permission. So I don't think code is complete when it doesn't have tests. So it's kind of like your responsibility as a developer, as a professional, to supply working code. That's probably in the contract you signed with the company, that you're going to try and create software to the best of your abilities. Well, if you're creating software without tests, then you're not creating software to the best of your abilities. So actually, you're just fulfilling your contract at that point. If they say it's still a waste of time, well, draw your conclusions then. Okay, I hope that answered. Also, there's this great book about that called The Phoenix Project. It's kind of a famous book, but if you haven't read it, I definitely advise it. It's how you can help your company understand IT and like technology and try and marry them a bit more together. It goes kind of deeper in topic, and there's like a lot of agile stuff, and great book, great book. Anyone else? Great.
Thanks, both our speakers.